So, good morning, good evening, good afternoon, wherever you are. Let's get started. First of all, I have to apologize for the mishap we had on July 19th. If you were tried to join our webinar, we were unfortunate enough to hit a very rare but happening event of outage of GoToWebinar system. So apologies again. Hopefully this time around we'll go forward without any problems. And while you're looking at this puppy, we have a couple of questions for you. So can we run the poll? So is your company actively adopting machine learning and artificial intelligence initiative? Yes, no, planning, no plans? Okay, 0 deployed in production, interested but no active ongoing projects is the most popular answer. Yeah, that's kind of what we expected. And we have a second question for you. Obviously, none of attendees are actively deploying ML and AI initiatives in production. What's stopping you? Okay, do not understand the capabilities, the lack of skill and talent. That's, again, what we expected. Okay. So let's see what industry leaders think about that. This is the results of the poll from Gartner, which is a leading IT analytical company in North America and probably worldwide. Only 4% of the respondents saying that they already deployed artificial intelligence initiative in production. Others either planning to do so or researching the subject or have no plans at all. Right? Reasons for that. Right? The most frequently stated reason is actually lack of skills, and our poll just confirmed that. Right? Here's another stats from Gartner. This time is not specific to machine learning and artificial intelligence, but lack of skills is stated as the leading barrier for success in various projects in various organizations. So let's see what kind of skills do you need to start machine learning. A lot of people think that you need data scientists. And data scientists are really hard to find on today's market. They earn 6-digit salaries, and probably the first digit is not 1. Data scientists with domain knowledge, data scientists, say, with clinical background or background in financial services, are unicorns. They are impossible to find. They don't exist. But do you really need to be a unicorn data scientist to start your machine learning journey? Let's see. So what you see on the right part of the screen is machine learning offering from AWS, Amazon Cloud. Right? Let's just give one of them a try. So you're logging into AWS Cancel, signing in, and here's our machine learning services. One of them is recognition, identifying objects on the images. Let's upload our demo image, which is a girl with the puppy. Actually, that's my niece and my puppy, so I got permission from both of them, so we're clear on the legal side of things. And let's see. It identified that we have human, we have animal. Animal is probably a dog, and Cocker Spaniel. It missed on the breed of dog. It's actually chocolate lab, but down the road, with slightly less confidence, it identified that we're dealing with lab. Right? Girls and puppies are fun, right? But practical application for this service can be multiple of them. For instance, in Portugal, a group of students used similar service from Google Cloud Vision to detect wildfires. Basically, what they do is they feed a whole bunch of images from various webcams to this service and literally looking for smoke. Like, is there smoke on the picture or no? If there's smoke, there's probably something going on then that needs attention. Right? If you are a developer, all you need to use this service is pack your image in the JSON and send it to the appropriate API endpoint, right? And parse the response that, again, JSON. There is no rocket science, nothing that requires unicorn skills to use these kind of services. Let's continue. Some of the other services you see here, for instance, Amazon Lex and Amazon Poly, is voice to text and text to voice, right? So if you are planning to build, for instance, intelligent answering machine, right? You have all the services available already. You don't need to train these services. You don't need to understand neural networks to empower your products with some elements of artificial intelligence, right? There's services for translation. There are chatbots, both open source and commercial available. So for instance, if you want to put intelligent chatbot on your website, you can do that in a couple of days using one of the either open source or publicly or commercially available libraries. So there's a whole bunch of services out there. But maybe you don't even need to use any of these services. Have you ever used this device, Amazon Echo? You at least heard about that. Amazon Lex and Amazon Poly are actually two services that Amazon Echo would use in the background. So the voice that you hear from this device is generated by Amazon Poly. Right? So maybe you don't even need to use these low-level services, and you can just develop applications, they call it skills, for Amazon Echo. And a bunch of our customers in healthcare already do that. For instance, Massachusetts General Hospital, right across the river from here, use Amazon Echo for surgery safety checklist. Northwell, another group of hospitals in New York and New Jersey, use that to notify patients about ER wait time. Where do you go if you have emergency with shortest wait time? Boston Children, they use Amazon Alexa to supply parents with discharge instruction. If family owns one of these devices, they would be able to follow up with a patient using one of these Amazon Echo devices, right? All it takes is develop skills. You can go onto a bunch of websites. For instance, Amazon itself provides a bunch of tutorials and trainings, and probably in half an hour you'll be able to build your first skill. Well, maybe you did your due diligence and you didn't find any pre-trained model or available library, and you need to roll your own. Right? And you start to think, oh, I need to understand all these libraries. It's hard to configure, hard to maintain. Think again. The easiest place to start, and I would really recommend you to go there if you want to do your own machine learning, is Kegel. Kegel is the website that hosts a bunch of competitions, bunch of challenges that you can participate at. They provide you with data sets you need to train your models. They provide you with a sandbox where you can actually train your models, and it's all absolutely free. So if you want to start with machine learning using, for instance, Python or Julia, you can do it there, and I would highly recommend this resource. Pre-built Docker images, right? If you have Docker installed on your machine, there's just two commands. First one would pull the Docker image with pre-configured TensorFlow environment, and the second one would run it. Like the first one would take a couple of minutes, well, depending on the speed of your internet connection. And let's just try the second one. So Docker is started. And here we go. We have a pre-configured Jupyter notebook with TensorFlow installed, and you can start machine learning right away with samples. For instance, means is considered hello world of machine learning, where you identify handwritten characters. Again, nothing extremely hard here. In the cloud, there are pre-configured machine images that you can use to train your models. And you might think about the cost of those images, because you probably heard that it requires specialized hardware, either GPU or TPU. Let's see how much it actually cost. So the data on the slide that you see right now is the cost to train service similar to Amazon recognition on either Google Cloud or Amazon Cloud. Google Cloud would use Google TPU, TensorFlow processing unit, specialized hardware. AWS would use a bunch of GPU, like your graphic cards that have been repurposed for machine learning specifically. Right? So the test itself, based on two well-known and openly available things. Thing number one is ImageNet dataset, is a set of annotated images that would have, this is the dog, this is the human, this is the watermelon, and so on, right? 1.3 million images, total size is 150 gigabytes, right? And the well-known, very popular neural network called ResNet50, neural network with 50 layers, right? There's a chance that Amazon recognition using exactly the same. But combination of those two is, by now, is kind of de facto standard in image classification benchmarking, right? So both Google and Amazon Cloud were able to train this model to 75% accuracy in under 9 hours, and with Google the cost was $55, and with AWS the cost was $129. The green bar doesn't exactly make sense here because that assumes that you are committing to use these instances 24/7 for a year, right? Unlikely you'll be doing that unless you're doing your machine learning 24/7. Right? So yes, there's a cost to that, but it's not thousands of dollars, right? It's pretty affordable. So what is machine learning? The best way to explain machine learning that I found is to contrast that to traditional programming. In traditional programming, you have the human being, developer, programmer, who writes the code. And this code turns input into output, some input data into output data. Data can be a variety of things. It can be voice, it can be text, it can be video, whatever, set of ones and zeros. And the code would convert it into another set of ones and zeros. If we do in machine learning, what's happening is not the human, but machine generates the code that turns input into output. In order to do that, that machine needs sample input and sample output. So if I give you this input, I expect the following output from you, right? So a bit spooky, machine creating machine, right? But if you're scared, maybe you're watching too many of Elon Musk's interviews, or maybe you have the point there. But there's a still role for human there. The role for human is to provide this, besides configuring machine learning algorithms, the role of human is to provide data. Right? Data have to be of high quality, otherwise you get garbage in, garbage out, and the high quantity. If you write in your code manually, you probably can come up with 100 or so fabricated records to test your model on. For machine learning, you need thousands or millions or billions records to train your model, and this data has to be real. You cannot train your model on fake data, otherwise you'll get fake results. Right? So there's a still role for human there. Now, let's say we start in a food delivery company in New York City, and we want to improve user experience for our customers. Someone with an accent like mine would probably start borscht delivery company. Borscht is a Russian soup, very popular. And we want to improve user experience by giving our customers an estimate on how soon they should expect their borscht to be delivered. Right? Ideally, we should record the whole bunch of trips our couriers already did across Manhattan. And based on that statistics, we would be estimating how long would it take to deliver borscht to our customers. But we're a startup. Yeah, we haven't delivered our first borscht yet. Luckily for us, City of New York City published the database of 3-year worth taxi ride and Uber rides that happened in New York City. Right? And this data set by itself is very interesting. So let's try to build a machine learning model based on that data. Right? To do that, we go to yet another notebook. In this case, it's a Zeppelin notebook. Actually, what you're looking at right now is our InterSystems Iris experience for machine learning. Like, I'm tweaking it a little bit at the end, but what you're seeing is what you'll get if you'll start InterSystems Iris experience, right? And a whole bunch of data already preloaded. You can analyze it either through standard SQL, through JDBC, or you can use Scala, which we'll be using down the road here, right? Fairly straightforward, right? You're looking for number of rides per hour, right? And obvious 5 a.m., lowest number of rides, 6, 7, the most popular time for taxi ride. Seems obvious and right. Right, let's move on. Now we switch into Scala, but you still can do the very same thing with Spark. And we're looking at number of rides per day. And here you can see the clearly weekly patterns, right? So this is most likely Wednesday, Thursday, the peak rides, and the lowest number of rides happens on weekends, right? So far, so good. We clearly see the trend, all right? Let's try the next one, right? Next one gives you the average speed depending on the hour of the day. And here we see something not normal, right? 5 a.m., it's expected, the lowest traffic, as we know from the previous graph. But something is clearly wrong at 9 a.m. There is no practical reason why 9 a.m. traffic should be faster than, say, 5 a.m. traffic or 6 a.m. traffic. Something fishy is going on there. If we look at the source data, right, let's scroll a little bit, right? You have few records there. With pick up and drop points with zeros, or the speed is exactly 0, right? So something is not normal. If the coordinates are 0, does that mean that whole bunch of New York taxis are picking up and dropping off passengers in the middle of Atlantic Ocean? Probably not. Most likely the GPS unit on the car is not functioning properly. So again, just a common sense. If you'll start to filter this data and let's say let's pick only the geographical area of Manhattan and surrounding areas, let's get rid of all the records that has unusually short distance or speed of 0, right? So unlikely the distance traveled on the car would be total 0. Something is going on there, and we'll just discard these records. If we do that, we would see the clear picture, clear trend. And by now we know that your speed is probably depend on time of the day of the week, and maybe distance you'll be traveling, right? So now we can start doing our machine learning with Spark, right? But basically, so far, all we did is just common sense, and we came up with a SQL, right, that gives us the clear data points, right? And we're doing some filtering based on geography, where we pick up and drop off passenger. We're doing some filtering for duration, so we're cutting off all the trips that show 0 duration. It's probably timer on our clock on the unit is not functioning properly. And we're trying to estimate how fast we'll be going. So this is basically what in machine learning is called feature engineering. That's what we did, right? We prepared the data, we prepared the features against which we will train our data model, right? The next thing we did is we load data from InterSystems Iris in here. We split the data set into 80% of training data and 20% validation data. Here's we set our features. We identify in speed type based on hour of the day of the week, and the distance. Right? I pre-run this notebook because it takes about 5 to 7 minutes, depending on what's going on in Google Cloud right now. It's a container that will provision for you, right? And as a result, right, you have your model trained with 68% accuracy. Okay. And if you output the human-readable version of this model, right, it kind of makes sense for decision tree. If you'll try to generate human-readable version of neural network, good luck with that. But still, we're looking at the human-readable. If we want machine-readable version of the same model, right, we'll be using a format called PMML, Predictive Model and Markup Language. That's industry standard format for sharing your pre-trained models, right? So let's do that. So the same model that we see here, we do see as XML. And this XML file we can copy paste and run this pre-trained model right in our systems. Let's do that. All right, we'll skip the boring copy paste exercise, but we'll validate our model independently from Spark using InterSystems Iris. Okay, let's go to our management portal, analytics, PMML model tester. Let's create new model based on the file that I created right before this presentation. Test New York City taxi, and import this file. Let's feed it with a data source, which is exactly the same data source as we used to train our model, but we just limit it to top 100 records. Right? Well, it's not exactly the same data set, but a data set with a different data, but in the same format. Right? And let's run it. It took probably a second, and we get similar accuracy. Right? We have correctly identified 67% of cases, incorrectly 33. Right? If you'll go to InterSystems Iris Experience, they would walk you through the process of improving accuracy of your model. Right? You'll be doing a whole bunch of things like switching from decision tree to neural network. You'll add a couple of more features, and eventually you'll bump up your accuracy from 67 to about 75% accuracy. Okay. So let's just recap what happened. Right? We started with data set of New York City taxi rides. Right? Oh, sorry. Yeah, that's. I have to show this. In order to get to the same Zeppelin notebook that I was just showing you, you can go to InterSystems Learning website, right, and subscribe to InterSystems Iris Experience. They have experience on identifying speed of your taxi, and they have experience of identifying fraudulent transactions, like financial fraud. But the flow would be similar to what we just went through. Right? It's absolutely free. All you need is to provide us with your email address and get the account. So we started with InterSystems Iris feeding a Spark machine learning library with sample input and sample output. So fairly large database, a few 100,000 writes. Spark ML did its magic, created and trained the model, validated the model. Then we exported this model as a PMML file, as XML file, machine readable. And we loaded this model back into InterSystems Iris. We compiled the class based on that model, and then we executed that. And actually, we executed that independently from Spark. So InterSystems Iris by itself is not machine learning platform, but it's perfect data source for your machine learning projects, and it can operationalize your machine learning by executing them right at the point of transaction, right at the point of service. Right? So you train it in Spark, you train it in TensorFlow, you move it into your application and run it as part of your workflow, as part of your service. So let's see how the similar approach is used in healthcare. HealthFix. HealthFix is a group of hospitals in New York and New Jersey, serving in total 16 million patients. They do have 1,500 locations across the New York City and New Jersey. Right? And they do use InterSystems HealthShare as a platform to aggregate and access all the data about all the patients generated in all of these locations. This data then being used by company HBI Solutions to build multiple machine learning models. They build around a couple of hundred different models to estimate risk of things like readmission, sepsis risk, chronic disease measurement, estimate cost, and so on and so forth. Again, few hundred different models. The workflow works like this. You have multiple hospitals that contribute data to the common system, to the InterSystems platform called HealthShare. This data can be in various formats. Most common is HL7 and CDA. Like InterSystems HealthShare does patient matching to make sure that John Smith in one record is the same John Smith that we previously have and not the other John Smith. It cleans the data, deduplicates the data. It does terminology translation, for instance, from ICD-9 to ICD-10. If there is a consent involved, some patients may want not to share their data, right? It also takes care of that. And optionally, the data is being de-identified. Right? So then this de-identified data is being shipped to HBI, to their own server farm, where they do machine learning using Spark and R. They train their model, they build their model, and then this model, as PMML, being shipped back to the InterSystems HealthShare platform and executed there already on the identified data on the real patients. For instance, if patient is about to be discharged from the hospital, so you see ADT discharge message, we will run model that estimate the risk of readmission. Right? Readmission as defined as the same patient being admitted to the same patient being admitted with the same diagnosis within 30 days. If risk is higher than a certain threshold, the protocol would kick in and home support worker or nurse would be calling the patient, making sure that he or her taking her meds and stay on prescribed data and taking good care of herself. Right, so basically we using here machine learning to improve quality of care and in some cases maybe even save life. Right? So on that note, I would say just that. It's not the rocket science. You don't have to be unicorn data scientist to start your machine learning journey. For instance, we at InterSystems started on the same path. Right? We were thinking, oh, we need data scientists. But then I said, hey, let's give it a try. Right? We engineers, we can do that. Right? We quickly identified that actually the missing resource was not the data scientist. The missing resource was clinician who would tell us exactly what to look for, what questions to ask your machine learning machinery, what kind of features the system might potentially need. So again, I would really encourage you to start machine learning journey despite presumed missing skills. It's not what's missing. What's missing is just getting started. And here I'll open floor for questions. Fabian, do we have any?
Yeah, so we have one simple question.
Mm-hmm.
You're talking in your demo about Spark Scala, and we heard that we should be using TensorFlow and Python. Can we use that with InterSystems?
Yeah, absolutely. As long as your machine learning framework can output the model in the PMML format, and TensorFlow and Python can do that, you can use it with InterSystems Iris.
Okay. Then one other questions we have. In your last slide, you can execute a PMML model in process on a single patient record and don't need health insight. Is that right?
Yes and no. The value of health insight is twofold here. All right, one is we're taking care of quality and quantity of the data. Right. Another one is we aggregating data about the patient. Like the fact that patient being discharged doesn't give you an idea of his medical history, of what medications he's on, his social factors, and so on. Health share and health insight, the part of health share that is actually being used there, would aggregate this data about the patient, including all the historical data, all the data from multiple facilities. Yes, in theory, you can do it yourself by aggregating all the data about single patient there, but health share already does that for you. So if you're able to collect all the data you need about single patient on your own, by all means you can do that, but it's a really challenging task. We learned it the hard way, but we solved that problem.
Okay. In one of the Global Summit talks, it was mentioned that InterSystems is planning a direct integration of R into the kernel. Are there any updates on that?
I would say stay tuned, and we planning a lot of activities around machine learning and artificial intelligence on the upcoming Global Summit, to which I would welcome you. It would happen at the end of September in San Antonio, Texas.
Okay. Where can we get the Docker images with Iris?
Docker images for Iris or for TensorFlow?
Both.
For TensorFlow, they publicly available on Docker Hub. With InterSystems Iris, I don't have an answer from the top of my head. I know they're available, but it's not Docker Hub, it's something else.
Yeah, you can download those from the WC distribution page.
Oh, here you go. The WRC distribution page.